A storm was born quietly in the South Pacific on April 5, 2026. Within 48 hours, it had a name. Within 72 hours, it had become a monster. Cyclone Vaianu tore across the Pacific with peak winds reaching 185 kilometers per hour, leaving a trail of destruction across island nations and eventually slamming directly into New Zealand's North Island. This is the full story of one of the most significant cyclones to strike the South Pacific region in recent years. Vaianu's origin lies in a cluster of tropical convection that the Joint Typhoon Warning Center designated as Tropical Cyclone 31P on the morning of April 5th. In the early hours, it carried sustained winds of around 75 kilometers per hour. By that evening, the Fiji Meteorological Service had upgraded it to a Category 1 system and assigned the name Vaianu. The naming of a cyclone marks a threshold moment. It means the system is organized enough, become dangerous enough, and has earned the attention of emergency agencies across the region. From that point, forecasters watch every movement closely. The intensification that followed was rapid and alarming. By April 6th, Vaianu had strengthened to a severe tropical cyclone status, the first to reach that classification in the South Pacific Basin since Cyclone Mal in November 2023. The atmosphere was favorable. Warm ocean temperatures, low wind shear, and high moisture levels allowed the storm to feed relentlessly. By April 7th, the Joint Typhoon Warning Center had classified Vaianu as a Category 3 system on the Saffir-Simpson scale, with 1-minute sustained winds reaching 100 knots, equivalent to 185 kilometers per hour. It was the first major cyclone in the South Pacific Basin under JTWC classification since Cyclone Lola in 2023. Vaianu was not just another storm. It had crossed a threshold that places it among the genuinely destructive. During its peak intensity phase, Cyclone Vaianu passed west of Fiji. The islands faced heavy rainfall, destructive winds, and rough coastal seas as the outer bands swept through. Surfers who had been at Tavarua Island chasing the famous cloudbreak wave found themselves scrambling to evacuate as the storm closed in. The scene captured something of the raw power of what was approaching. People who had been in the water hours earlier were now racing to get off the island before conditions became life-threatening. Fiji Airways flights during this period reported severe turbulence, with passengers reportedly left ill by the violent movements of aircraft navigating the storm's outer edges. The Fiji government issued weather updates tracking Vaianu's movement as the storm passed through the region, with warnings for coastal communities and low-lying areas. Tonga also came within range of the storm's influence. The Tonga Meteorological Service issued strong wind, heavy rain, and gale warnings for Tonga Tapu and Iwa as Vaianu tracked southward. Island communities across this part of the Pacific are acutely vulnerable to cyclones. Coastal infrastructure, homes built to withstand everyday conditions, and communities that depend on fishing and agriculture all face extreme risk when a major cyclone moves through. The wave heights generated by a Category 3 system are capable of causing storm surge events that push seawater far inland, destroying crops, contaminating freshwater supplies, and demolishing buildings. After reaching peak intensity, Vaianu began a weakening trend, increasing wind shear, drier air being drawn into the circulation, and the cooling effect of deeper, less warm ocean waters all worked to erode the storm's structure. By April 8th, the JTWC had downgraded it to Category 1 intensity. By April 9th, the final advisory from the JTWC noted that Vaianu had hybrid characteristics, partly resembling a subtropical storm rather than a pure tropical cyclone with a partially exposed center and weakening convection. Wind shear of 30 knots was tearing the storm apart. This is what the end of a tropical cyclone typically looks like from the data, but weakening on paper does not mean safety. A storm with 55-knot sustained winds is still capable of producing dangerous conditions for any land or coast it encounters. And New Zealand was directly in Vaianu's path. New Zealand Prime Minister Christopher Luxon confirmed that government agencies were placed on full notice as the storm approached. On April 8th, Met Service New Zealand issued a preliminary severe weather watch for the entire North Island, acknowledging that Vaianu's remnant system posed a significant threat. By April 9th, Earth Sciences New Zealand forecast that some areas could receive up to 200 millimeters of rain within an 18 to 24-hour window once the system made landfall. That number matters. 200 millimeters of rainfall in less than a day is enough to saturate soil, trigger landslides, overwhelm stormwater systems, and turn roads into rivers. In the days before landfall, supermarket shelves in the upper North Island were cleared by panic buying. Families stocked up on essentials, filled containers with water, and made plans to shelter or evacuate. On April 10th, a precautionary state of emergency was declared in the Northland region. The following day, states of emergency were declared in multiple districts, including Wakatana, Hawke's Bay, Waikato, Tauranga, and several areas across Bay of Plenty. The Waikato Civil Defense Emergency Management Group declared a state of emergency for the entire region on the morning of April 11th, a rare step that reflected the potential scale of what was coming. Emergency mobile alerts were sent to smartphones across Auckland and Northland. Residents in coastal zones were urged to evacuate and to not wait for official evacuation orders if they felt at risk. Met Service meteorologist Heather Keats made a point during pre-landfall briefings that should have stayed with everyone listening. She said that the eye of the cyclone is not the only problem. Some of the worst weather New Zealand experiences with cyclones arrives hours before the eye itself. The outer bands, the feeder rain bands, the escalating winds well ahead of the center, all of these can produce dangerous and damaging conditions long before the main event arrives. She described Vaianu, even in its weakened state, as a very large, damaging system. Cyclone Vaianu made landfall near the Maketu Peninsula in the Bay of Plenty shortly after 2 p.m. local time on Sunday, April 12th. The timing was devastating. Gale-force winds of up to 150 kilometers per hour coincided almost exactly with high tide at 2:20 p.m., producing the worst possible combination of wave height, storm surge, and rainfall impact at the same moment. The Wakatani District Council warned residents that storm surges and potentially 12-meter high waves were forecast to coincide with high tide, representing the highest risk phase of the entire event. Coastal communities like Ohope and Thornton were ordered to evacuate. Anyone living in coastal and low-lying areas across Tauranga and Western Bay of Plenty was advised in the strongest terms to self-evacuate without waiting for a formal order. The storm surge and coastal inundation that followed hit communities that were already exposed. Fire and Emergency New Zealand confirmed it responded to 100 calls related to line damage and surface flooding during the height of the event. Wakatane saw 270 properties under evacuation orders as conditions peaked. Gisborne was cut off from the rest of the North Island as parts of State Highway 2 and State Highway 35 were closed, remaining shut until midday on Monday. Thousands of properties across Bay of Plenty, Coromandel, and Waikato lost power during the storm. More than 3,000 customers remained without electricity in the central North Island on Monday morning alone. The rainfall totals recorded were staggering. The Coromandel Peninsula recorded 220 millimeters of rain during the event. Wind gusts at Mahia reached 126 kilometers per hour. The storm tracked southeast across the North Island before moving offshore from Hawke's Bay on the evening of April 12th. Interestingly, forecasts had pointed toward a direct Hawke's Bay impact, but the system veered eastward out to sea when it reached Wairoa, sparing the Hawke's Bay region from the worst impacts seen further north. Nonetheless, over 580 households across coastal Hawke's Bay communities had already been told to evacuate, with mandatory evacuations applied to approximately 50 homes in Hamoana. The damage assessment that followed landfall painted a picture of widespread destruction across the North Island's east coast. Flooding hit Coromandel, Waikato, and parts of Auckland. Wastewater systems in some eastern coastal communities came under severe strain as floodwater overwhelmed drainage networks. Roads were blocked by slips and debris. Power restoration crews worked through hazardous conditions to begin reconnecting properties. The cleanup was expected to take days, with residual risks from landslides, and unstable slopes persisting well into the week following the storm. Met Service maintained weather watches even after the main system had cleared, with ongoing shower and thunderstorm risk keeping recovery workers and residents on alert. By the morning of April the 13th, Cyclone Vaianu had moved southeast toward the Chatham Islands and begun dissipating. Met Service lifted cyclone-related watches and warnings progressively as conditions improved, though advisories remained in place for some coastal areas. States of emergency in Tauranga and Hawke's Bay were lifted that morning. The process of assessing structural damage, clearing roads, and restoring services was well underway, but for communities that had experienced the full force of the coastal surge and rainfall, recovery was going to take far longer than a single morning. Cyclone Vaianu arrived at a moment when New Zealand was already grappling with questions about its resilience to severe weather events. The country has faced a series of damaging storms in recent years. Each time, the conversations that follow focus on infrastructure, on flood protection, on drainage capacity, and on the speed and effectiveness of emergency response. Vaianu will add its name to that list and will almost certainly sharpen those debates. The National Emergency Management Agency, local civil defense groups, and Met Service all performed the kind of rapid, coordinated response that reflects experience from previous events. The early declaration of states of emergency across multiple regions allowed resources to be pre-positioned before conditions deteriorated. Lives were likely saved by that early action. What Vaianu also demonstrated is the compounding nature of tropical cyclone hazards. Wind speed is the number that gets the attention, but it is the storm surge, the rainfall, the flooding, the landslides, and the infrastructure failures that determine the true cost. A system that weakens from Category 3 to a subtropical storm before landfall can still produce a coastal surge capable of killing people if the timing aligns with high tide. The 12-meter wave forecast for Wakatane, and the coincidence of that surge with the 2:20 p.m. high tide on April 12th, is precisely the kind of compound event that turns a manageable storm into a life-threatening one. The The South Pacific cyclone season typically runs from November through April. Vaianu's arrival in the second week of April means it came at the trailing edge of the season, but that offered no comfort to the communities in its path. Nature does not observe calendar boundaries. What matters is the ocean temperature, the atmospheric conditions, and the track of the storm. All three aligned in April 2026 to produce a system that caused real and serious harm across the Pacific, from the shores of Fiji and Tonga through to the east coast of New Zealand's North Island. The cleanup continues. The questions about preparedness and resilience will continue long after the last debris is cleared. The storm surge element of Cyclone Vaianu deserves particular attention because it is the least understood hazard among the general public, yet one of the most deadly. Most people think of a cyclone primarily in terms of its wind. They picture flying debris, downed trees, and damaged rooftops. All of those hazards are real, but a storm surge is something categorically different. It is a wall of ocean water pushed ahead of and alongside a cyclone by sustained wind force, arriving at the coast with enormous energy and volume. When that surge coincides with a high tide, the combined sea level can rise to heights that overwhelm seawalls, inundate ground floors, submerge roads, and push water into buildings with a force that no amount of sandbags can fully stop. During Vaianu's approach, the Wakatan District Councils specifically warned residents about the combination of storm surge and high tide occurring in the early afternoon hours of April 12th. The forecast of up to 12-meter swells arriving at that exact moment represented an extreme event for coastal communities that sit close to sea level. For residents in Ohope, a coastal community with homes directly fronting the ocean, the instruction to leave and to leave immediately was not precautionary excess. It was a reflection of what storm surge data and tide timing made plainly clear. Staying in those homes during that window could have meant death. Storm surge events from tropical cyclones have historically accounted for the majority of cyclone-related fatalities worldwide. Communities that sit on low-lying coasts, particularly those near bays and estuaries where surge energy concentrates as water pushes inland through narrow channels, face the highest risk. The Bay of Plenty's geography, with its curved coastline and coastal settlements built close to the water, placed it directly in the most dangerous category of exposure. Emergency managers knew this in the days before landfall, and their messaging reflected it. The instructions to stay away from the coast were clear, repeated, and emphatic. Coastal flooding and surge, as Wakatani's civil defense warned publicly, can occur suddenly and can kill within minutes. Recovery from a compound flooding event of this scale is not simply a matter of pumping water out and fixing fences. Saturated soils remain unstable for days or weeks after a major rainfall event, meaning landslide risk persists long after the storm is gone. Road surfaces undermined by floodwater may look passable, but carry structural weaknesses invisible from above. Wastewater systems contaminated by stormwater inflow pose health risks to communities relying on tap water. Power infrastructure damaged by falling trees and wind stress requires careful inspection before restoration. For the communities in Bay of Plenty, Coromandel, Waikato, and the East Coast that took the full force of Vaianu's passage, recovery is a multi-week process that extends well beyond what news coverage tends to follow. What Cyclone Vaianu has reinforced, once again, is that the Pacific's cyclone season demands sustained attention and genuine preparation from every community in its potential path. The forecasting tools available today are far more sophisticated than they were 2 decades ago. Met Service, the Bureau of Meteorology in Australia, and the Joint Typhoon Warning Center all provided accurate and timely information about Vaianu's track and intensity throughout its life cycle. The question that always follows events like this is not whether the warnings were given. They were. The question is whether communities, governments, and infrastructure systems are consistently ready to act on them with the speed and scale that the situation demands. Cyclone Vaianu has given the South Pacific another hard and expensive answer to that question. There is also a broader climate context that meteorologists and scientists track carefully when a storm like Vaianu develops. The South Pacific is a basin that has seen notable cyclone activity in recent years, with systems reaching intense categories at times that challenge the notion of a clearly defined and predictable season. Ocean surface temperatures in this region have been running above average during several recent years, and warm water is the primary fuel that drives tropical cyclone intensification. A sea surface temperature even 1 degree above the historical average can provide meaningfully more energy to a developing storm, allowing it to strengthen more quickly and maintain intensity for longer periods. Vaianu's rapid intensification from Category 1 to Category 3 in roughly 24 hours is a pattern that meteorologists describe as one of the more dangerous features of modern tropical cyclone behavior. It gives communities and emergency managers less time to respond and makes final hour decision-making more consequential. When a storm that was forecast to be moderate becomes severe or major within a day, the gap between planned response and required response narrows sharply. Every hour of preparation time matters enormously. when people need to evacuate coastal zones, pre-position rescue equipment, or open emergency shelters. New Zealand has learned these lessons before. Cyclone Gabriel in February 2023 caused catastrophic flooding and loss of life across the North Island, and the country's emergency management systems were substantially reviewed and strengthened in the aftermath. Vaianu arrived as a test of how much of that strengthening had translated into practice. The early state of emergency declarations, the pre-positioning of water rescue and specialist teams, and the public messaging around coastal evacuation all reflected lessons drawn from Gabrielle. Whether the physical infrastructure has caught up with the level of risk remains a question that will be examined in detailed reviews over the coming months. For now, the South Pacific waits and watches. The official cyclone season does not fully close until the end of April. As the atmosphere cools and the season's window narrows, the probability of new storm development drops. But, as Vaianu has demonstrated, April storms are not minor weather events. They carry the same destructive potential as any cyclone formed at the height of the season, and they arrive at a moment when some communities have already reduced their cyclone readiness, believing the worst to be over. That assumption, as April 2026 has shown, can be a costly one.